Hello, Algebra 2. We have section 8.4, graphing rational functions today. A rational function is when we're taking one function divided by another. This example here we have f of x equals a of x divided by b of x. And kind of like yesterday, we're still focusing on vertical asymptotes. And we'll be talking some more about horizontal asymptotes, and then part 2 of 8.4 will be oblique asymptotes or slanted asymptotes. Okay? So, our function will have a vertical asymptote wherever the bottom function or the bottom part equals 0. That'll give us our verticals. That's kind of what we worked on the other day. Okay, we can only have one horizontal asymptote or none at all. So your horizontals are either going to be 1, not actually like equal to 1, but we could have either one of them or none of them. How do you know? Okay, if the degree, the highest exponent or the exponent on the top, is bigger than the degree on the bottom, there's going to be no horizontal asymptote. If the degree on the bottom is bigger than the degree on the top, then our horizontal asymptote is at y equals 0. And the tricky one is when the degrees are equal. Like if we have an x to the third on the top and an x to the third on the bottom, okay, then we divide the coefficients that are on those degrees, or on those exponents, to get where our horizontal asymptote will be. So here's an example like that. If we had like 2x to the third plus 1 over 3x to the third minus 2. Okay? These are tied for the degree. They both have a highest exponent of 3. So I divide the leading coefficients 2/3, and my horizontal asymptote would be at 2/3. That's only if they're tied. Okay? If the bottom is bigger, like if we have x plus 1 over 2x squared minus 2, if the bottom is bigger, we have an x squared compared to just a regular x, then we're going to have a horizontal at y equals 0. And if our top is bigger, x to the third over x plus 1, then we're not going to have a horizontal at all. Okay? Alright, so we're going to state the asymptotes of each function. We got some examples here drawn up. Okay, so for x to the third over x minus 1. So let's first do our vertical asymptotes. Okay, what's going to make the bottom equal 0? Positive 1. Okay? Positive 1 make the bottom equal 0, so that's my vertical asymptote at x equals 1. Will we have a horizontal? X to the third is the highest one up here, x to the first down here. So the degree of the top is bigger than the degree of the bottom. 3 is bigger than 1. So no, we won't have a horizontal asymptote. Here we have x plus 1 over x squared minus x minus 6. Okay? So to get my vertical asymptotes, I'm going to need to factor that out. This is going to factor out to x minus 3, x plus 2. So what makes this equal 0? 3. What makes this equal 0? Negative 2. So my vertical asymptotes are going to be at 3 and negative 2. Will I have a horizontal? Okay? The top of mine is x to the first. The bottom has the highest power of x squared. So the degree of the bottom is bigger than the degree of the top one. So we'll have a horizontal asymptote at 0 because the degree of the bottom is bigger than the degree of the top. And our last little example here, kind of like our one we did on the front page, 2x minus 3 over x plus 1. Our vertical asymptote is going to be at negative 1, whatever makes the bottom equal 0. Do we have a horizontal? x to the first on the top, x to the first on the bottom. They are tied, so yes, we will have a horizontal. How do we figure it out? Divide the leading coefficients. So there was a 2 on that. Really, there's a 1 on this, 1x. So 2 over 1 is going to be our horizontal asymptote. Alright, now that we have the basics down, let's go forward here with an actual problem from your homework. Okay, this is going to be pretty similar to what we've been doing. Okay, we're just going to get asymptotes down first, and then we will go through our calculator to graph the actual function. Okay, so here we have 2x over x plus 3. Okay, what's going to make my bottom equal 0? Negative 3. So that's where my vertical asymptote's going to go. Negative 3. Alright. Next, horizontal asymptotes. The top and the bottom both have the same degree, x to the first, x to the first. Alright, so I divide the leading coefficients. 2x over 1x is going to equal 2. So my horizontal asymptote is going to be at y equals 2. Okay? From there, we can type this in to the calculator. 2x divided by parentheses x plus 3 and graph. Okay, we can kind of see where we're at there. And we need some points to plot out, just like yesterday's. Okay, so our vertical asymptote was at negative 3. So how about we trace, and let's go with like negative 3.5, just past negative 3. And we're at 14, that's going to be way off the graph, not going to help me out. How about negative 4? Coming down to a more reasonable negative 4, comma 8. So at negative 4, we'll go to 8. 1, 2, 3, 4, 5, 6, 7, 8. We're up here. How about negative 5 is going to be at 5. 1, 2, 3, 4, 5. Negative 6 is going to be at 4. Okay, we can get the idea of our curve. Coming down and flattening out, following our asymptotes. Okay, on the other side, so this was negative 3, where our asymptote is, so we need to be on this side of negative 3, like negative 2. Okay, at negative 2, we're going to get negative 4. 1, 2, 3, 4. Negative 1 is going to be at negative 1. 0 is 0. 1 is at 0.5. And you can kind of see that we're going to really level out and flatten out pretty quickly. So we got our curve looking like that. Okay? How'd we do? Look pretty good? Pretty similar? I think so. Alright, let's try another one. Okay? You hit pause and try this one on your own. Alright, where's my vertical asymptote going to be? What makes this equal 0? At x equals 2. Okay, the top, x to the third, is bigger than the bottom, x to the first, so we won't even have a horizontal. So this isn't too bad. Okay, so we're just going to have one at 2. For horizontal. Alright, we're ready to type it in. X to the third divided by x minus 2. Graph. Yeah, alright, let's zoom out and see if we get any bigger there. Oh, it pops back up way up there. This is going to be a tough one. Okay, tough one for points. So let's go just to the left here Let's try it 1. Trace 1. Well, we got 1, negative 1. 0 is 0. Negative 1 is going to be at 0.3. Negative 2, we're at 2. We can kind of see that we're going to be coming down like this and flattening out this way. Okay, to the right is going to be the tough part here. Let's check out 3. 3 is going to be way up here at 27. And 4 is at 32. We're already on the way back up. So we're going to have just a little mini guy right here going up like that. Alright, if that's the case on your homework where one's way off the screen, just do the best that you can. I don't think we would have one like that on a quiz or a test. It would fit nicely on our graph for that. Okay, so your homework is going to be on the board today. It should only be 5 or 6 problems, so you shouldn't have any problem with that. Make sure we get that done, make sure we're doing our work, and we'll see you guys tomorrow.